Today we're just going to talk about the checks on suspension. Obviously we won't ignore steering where it's relevant, because we'll be taking a look at steering in a future programme.
Now the manual has diagrams of various suspension types, doesn't it?
But it's just as you say, Robert, they're diagrams. When you're under a vehicle, it's not always easy to identify the various types. So what I'm going to do is I'm going to show the different types from under a vehicle and then discuss all the issues relating to suspension. But of course for that we'll need test equipment.
Okay.
Right, as usual before we start there's a few things we need to know. Firstly, equipment, a suitable pinch bar for checking for wear and play, a pit or hoist where the wheels can be jacked, and don't forget you may need to use the corrosion assessment tool.
And Tom, obviously this covers front and rear.
Yes, it does.
Can we just go back to the equipment for a moment?
Yeah.
You wouldn't need a pinch bar on an automated test lane, would you?
I am glad to see you're keeping up to speed, Robert. Right. Although the wheel plate detectors shake the suspension, you may still need to use the pinch bar because the wheels will need to be jacked.
And what about the differing suspension types on an ATL?
That's not a problem. It can be used on all types.
And do we need an assistant, Tom?
Yes, although we'll be using here ATL, we'll be using it in manual mode. Now, if this were a real test, the assistant would be in the vehicle now, ready to help with steering and brake checks.
Wouldn't you test the shock absorbers with the vehicle on the ground, Tom?
That's quite right, and most testers would check for the damping effect during the topside inspection, and they'd look under the bonnet and in the boot for any suspension attachments. Now, there's something else I need to explain here. Always take care pushing down on the corners of the vehicle when checking for the damping effect. It's really important that nobody gets hurt and no damage is caused. As an alternative, testers can pull down on the vehicle during the underside checks.
And I believe some vehicles were actually built without any shock absorbers.
That's true, and it's only a failure if they don't have any when there were shock absorbers originally fitted.
What else are you looking for on shock absorbers? Security, corrosion, damage?
Yes, we are, and we're also looking for excessive wear and a shock absorber linkage, pin or bush. And the bounce test, negligible damping effect. And any leakage serious enough to indicate that the fluid seal of a shock absorber has failed.
But there can be slight seepage from them, can't there?
Yes, there can, and that's not a reason for rejection.
So are we going under this vehicle or what?
Don't rush me, Robert. I am an engineer. This vehicle's got McPherson strut suspension, as in diagram 4 in the manual, and it's one of the more common suspensions you'll find on vehicles these days. Right, Robert, I've got this little video probe so we can get right in there to the suspension components. But before we start looking at components, I need to make a point about corrosion and prescribed area.
And of course, we both covered this topic in a previous film.
Yeah, we did. So rather than describe it all again, I'd just like to remind everybody that those checks can be found on the back catalogue DVD under the body and structure section.
Great.
Right. First, I want to talk about checks that are on all vehicles. Yeah. So they would need to check if there's enough clearance between axle or suspension unit with the bump stops or chassis. Also, they need to check that there is no suspension unit so weak that it cannot keep the body far enough away from the road wheels.
If the bump stop's missing, is that a reason for rejection?
No, it's not.
So what are the criteria for rejection, Tom?
Well, rather than repeat myself, so to speak, all suspension components and their fittings, and that includes McPherson strut casings, they'll be failed for cracks and or fractures. The exceptions to this are shock absorbers, drive shafts, and fluid gas or their suspension units.
Is that all?
No. Any leaf spring repaired by welding, any coil spring or torsion bar repaired by welding or damaged by excessive heat, they both fail.
So it isn't a case of every reason for rejection applying to every component?
Exactly. Another example, any suspension retaining or locking device missing, ineffective or not properly locked. And the same goes for any linkage pins on upper and lower suspension arms, wishbones, trailing radius arms, tie bars and rods, panhard rods, torque reaction arms. There's anti-roll bars and linkages, and last but not least, subframes.
And when you say retaining, you mean any bolt, nut, weld, rivet, etc.?
I do, and when I'm talking about locking devices, I'm talking about split pins, shake-proof washers, locking compounds, and so on.
Now, Tom, I think we've said this before, but it's not always possible to determine the effectiveness of some types of locking devices, for example, self-locking nuts. Only the presence of these devices is a test requirement, isn't it?
That's exactly it. So if using the methods of inspection, the tester's satisfied that it's there, then it passes. Oh, one other thing. If you hear me say loose, that means there must be relative movement between the components.
Gotcha. And on this vehicle, you've got a coil spring to check.
Yeah, and apart from the things I've already mentioned, we'd be looking at the general condition and location of the spring. So the reasons for failure are worn or corroded, so that its cross-sectional area is reduced, making it seriously weakened, a spring not correctly located, a spring mounting, seriously weakened by damage or corrosion.
And security of all the rods, arms and linkages that you mentioned earlier?
Yeah, and also if they're severely distorted, seriously weakened by corrosion or wear, if they're adjustable and they're loose in the threads or the locking device is missing or insecure, seriously weakened by deliberate modification, an anti-roll bar not fitted where it's a standard fitting, inadequate repairs, and the fail criteria for those repairs are in Appendix C, by the way.
Some vehicles use comparatively thin gauge steel pressings on some highly stressed suspension components, don't they?
They do, and some of them have hollow box sections or up-facing areas where dirt impregnated with salt or other chemicals can collect and cause serious but often very local corrosion. Now these need special attention because the fail criteria for highly stressed components is not the same as prescribed area. And once again, the guidance for this is in Appendix C.
Presumably different components have different fittings.
Yes, and they need to be looked at too. So pins and bushes, we check them for play. And there are some specific dimensions in the reasons for rejection in the inspection manual. We also check suspension ball joints for excessive play, suspension locating pins for incorrectly positioned or insecure.
And I take it you can use the pinch bar to check these items?
You can, but you must take care not to cause any damage.
And some rubber bushes are designed to have a fair bit of movement, aren't they?
They are, and they should normally only be rejected if there's serious deterioration of the bonded or flexible material evident.
Now, all those types of rods and arms that you spoke of have attachment brackets and mountings. What do you check them for?
Apart from what I've already mentioned, we're going to check them for security, damage, corrosion or wear to such an extent that their strength is seriously reduced, once again inadequately repaired, or a component seriously weakened as a result of deliberate modification. Earlier on I mentioned about the little probe, video probe, so if I get that and we start looking at some of the components that we've been talking about, and you've got a little screen there, you can see it there.
Yep.
So if we're looking right up in here, and you can see where the spring's located, the McPherson strut and casing, and that's an up-facing area where impregnated dirt can get. Yeah? And as you come down, you can see here the bolts that attach the hub to the McPherson strut. Can you see that?
Yeah, I can.
There's the retaining bolts and their locking devices. And then you come on down here, and you can see there's the ball joint and its retaining devices. And then the bottom wishbone arm, which is one of those highly stressed components that we've just discussed. And then up in here, you can just about see the locations of the wishbone arm. Can you see that? That's got those flexible mountings we talked about. And then if you look just around there, there's the mounting for the anti-roll bar. I'll just see if I can pick up. Yeah, there's the other end of the anti-roll bar, and there's the link up onto the suspension. You see that?
Yeah, just on the right-hand side.
Going right back up the McPherson strut again. So that a lot of the things we've been talking about.
Rare, I know, Tom, but what if the drive shaft forms part of the suspension?
That's a very good point, and not as rare as you might think. These types can be found on the rear suspension of some Jags, for instance. Now, in this case, the drive shaft would be a suspension component, and we would check the drive shaft for distortion, damage or serious corrosion, the UJ bearings for excessive play, the flanges and bolts for presence and security. And normally we do these checks when the vehicle is jacked because it's much easier. But I'd like to come back to this vehicle. Now, at the moment we've got this jacked, and that was for the purposes of the discussion we've had and the filming we've been doing. Now, I need to make the point that it's vital that suspension is jacked correctly. And the diagrams in the manual show us where to jack for the various types of suspension, and I'll talk more about that later. Now, this is a McPherson strut. So the jacking point is here to allow the wheels to hang freely. And while the vehicle is being jacked, you should check the movement of components. Now, on this vehicle, you'll be checking the suspension ball joint, tie bar joints, and McPherson strut suspension upper attachment.
And that's diagram 4 in the manual, isn't it, Tom?
Oh, dead right, Robert, yeah. Now, you would jack in the same way and do similar checks for suspension types 3. That would be like Mini or Metro, for example. Yeah? And also for suspension types 3A, some Renaults spring to mind.
Very droll, Tom.
Okay, and what we need to do is get out from under this vehicle because we're going to do some checks from the outside.
Okay.
Yep. For these checks, I'm going to use a heel bar. Yeah, and that just means this is a lever that I can push downwards and it raises the road wheel upwards. Yeah, so I just place it under there. Now for suspension types 3, 3A and 4, you know, while I'm levering it upwards like this, yeah, I'm going to check for play in suspension ball joints, tie bar joints and McPherson strut upper attachments. Yeah, then I'm going to get hold of the wheel and rock it by hand, or I can use a lever bar in the wheel to rock it if it's appropriate. I tend not to put my hands right under the wheel. I'll just rock the wheel like so, yeah, and also check for any movement in suspension components.
What about other types of suspension?
Same methods of inspection are used, it's just we check different items. So for example, figure 1, which is beam axle, I'm going to check for excessive vertical movement between the stub axle and the axle beam. This is usually referred to as lift. So for suspension types 2, which are parallel wishbones, for example, or 2A, which are torsion bars, I'm going to check for vertical movement between the swivel and housing and movement in the wishbone bearings.
Are those jacked the same way?
No, for the types in figures 1, 2 and 2A, the suspension's not allowed to hang freely. So the jacks are placed under the suspension, it's supported as the vehicle is raised, so that all the components are kept away from their stops, and there's no load imposed on any of the joints.
Wouldn't the wheel play detectors do all this for you?
Not really, you can check most things, but for example, you can't check roughness in the wheel bearing. So let me demonstrate those wheel bearing checks, and when you do this, the ignition needs to be switched off. Yeah. So just check for play and then rotate the wheel, feeling for roughness in the bearing, and then rotate it and listen to a noise indicating roughness in the bearing. And you'll carry out these checks on all the wheel bearings. The only time you won't check for roughness in a wheel bearing is if the characteristics of the vehicle don't allow it.
Now, Tom, I couldn't help noticing that you can't see all those components.
It was that obvious, was it? Okay, yeah, that's a really good point, because as the assistant, you're now going to carry out those methods of inspection, and I'm going to go around there and have a look. And that way, I've got to feel it, and I get to see it. Yeah? So we swap places, and you grab that heel bar. Yeah, just place it under the wheel, and start to lever it up. I'm going to duck under here, and I'll use this little device again, little probe. Yeah, and we can see suspension ball joint. Yeah. Inner wishbone joints, and then I can look right up in here and I can see the McPherson strut upper attachment. Lever it a bit more. Yeah, that's grand. Okay, now then if you want to grab the wheel, because you're going to rock the wheel now, and just try and get it just down here but not right underneath, and just rock the wheel. Same checks again. Go and look at all the suspension component joints this time. Yeah. Okay, that's that. Right, now we move on to the next bit.
And do you look at the front drive shafts?
Yes, we do. And when we're carrying out those checks, What we do is we move the road wheel round onto lock, like that. Yeah. Then we rotate the wheel as we carry out the checks. I'll tell you what, you know what we're looking for because we've discussed that from the manual. Yeah? So if you call it out, and I'll use this little video probe, and so we can film the different components as you describe them.
Yeah, okay. The first is outer constant velocity joint gaiters missing, split, or insecurely mounted to their housing.
Okay. So that's the outer constant velocity joint gaiter. Checking for splits, checking the security, and checking whether it's secure to the housing. All right.
Drive shaft constant velocity joints excessively worn or insecure.
Okay. Well, that's the same joint that we're talking about. So we rotate that for any problems with it. Yeah.
Drive shaft couplings excessively worn or insecure.
Okay. Get the camera on that one. So that's that there on film. Yeah. Okay.
Drive shaft flexible rubber or fabric coupling units, severely cracked or breaking up.
Yeah.
Softened by oil contamination.
Yeah.
Insecure, or fouling any other parts of the vehicle.
Right, now those are the kind of components that are fitted, say, to the earlier Minis, or there used to be a vehicle Triumph Toledo. So those reasons for rejection relate to those earlier type of vehicles.
And the drive shaft itself?
That's a good point, and I would have got there eventually. Yeah, so we're going to check the drive shafts, if they're bent or damaged. Yeah, so just, you can see the drive shaft there as we rotate it.
Yeah.
And the continuation of the drive shaft under here. And we're also checking insecure or fractured fasteners securing a drive shaft coupling bearing. That's that there. Right. And then what I'd do, I'd move the wheel round to the other lock. And then I'd look in from that direction with the lamp, and I'd check all those same components again to make sure that I'd carried out all those checks. And that's it.
Great.
And then the next stage is we're going to drop the wheels onto the turn plates, and the turn plates will be free moving so that the wheel can be moved from lock to lock, and they're bearing the weight of the vehicle. Now, when you carry out this process where you drop onto the turn plates, it's very important to get the plates set up in the correct position. I've seen many testers dropping them down onto the turn plates, and as the vehicle lowers and the track expands, it forces the plate right up to the maximum position, and then the plates aren't free moving. Yeah? So we'll make sure we get the plates set up before we do that.
Okay.
So now we've got the wheel resting on that free moving turn plate, and it's bearing the weight of the vehicle. And this is the hard bit. I'm going to grab the top of the wheel, yeah, and just push it and rock it straight in and out. Yeah? And I'll be checking suspension components. Right? See it moving on the turn plate. Yeah? And then I'll grasp the wheel at 9 o'clock, 3 o'clock, and shake it vigorously. Once again, checking suspension components. You got that?
Yep.
Now, as we discussed before, I can't see very much. No? But I have carried out the checks and I've felt, if there was anything to feel, I would have felt it. But now as the assistant, you're going to do that same work again, and then I can look at the suspension components. And what I will do while we carry that out is I'll use that little video probe and see if we can film them.
Okay.
Yeah?
Yep.
All right. Okay, let's see how we get on. So if you grasp at the top and start shaking it in and out, and I'm checking the suspension ball joint. Yeah. I'm checking that locking nut up there to make sure that's secure and in position. I'm checking the suspension inner wishbone joints. And then I can come up here, I can check the McPherson strut, upper gland there, upper attachment, and for any roughness in that upper bearing. Okay, you stop there.
I need to rest.
It's not easy, and it's a lot to check. Okay, so have a little breather for a moment, because then you're going to have to grab it at 9 o'clock, 3 o'clock, and do the other checks.
Okay. All right, let's do that.
All right. So, away you go. Start shaking it in and out, and I'm going to check for, once again, excessive play in the outer ball joints. Yep. backing mount, and I'm going to check those inner track control arm or wishbone bushes once again, looking at those. Looking for serious deterioration between the bonding of the rubber and the metal of and those flexible materials. And once again, we're going back up to the McPherson strut, upper support bearing. So we're carrying out very similar checks. Are you all right there, Robert?
Yeah.
Okay, I'll let you stop now, because the beads of sweat are on your brow. Well done.
It's not easy being an assistant, is it?
No, it isn't easy at all. But don't forget, if you weren't filming this, you wouldn't have been shaking it for anywhere near as long
And
as
thank
that.
goodness the ATL does the shaking bit.
Yeah, but the test has still got to check for condition of the suspension components.
Okay, so it's rear suspension next.
Yes, it is. And when we jack the rear suspension, ideally we should hang that suspension. Yeah. And then we've already discussed the wheel bearing checks that would be carried out. And while the suspension's hanging free, all the other suspension components around it, there's an opportunity then to check them for their conditions, security, and so on. All the things we've discussed.
Tom, so far you've mentioned in detail the checks on coil springs. What about other types?
Fair enough. Let's talk about leaf springs. They're not so common these days, although there's still quite a few of them around, particularly on light goods vehicles. And we'll start by talking about the condition of the springs. Yeah. So, a leaf which is permanently distorted due to damage or so deteriorated that it's seriously weakened or has a defective spring eye. The leaves of a multi-leaf spring splayed to such an extent that the action of the spring is impaired or will foul other parts of the vehicle. The leaves for longitudinal displacement. A spring fitted so as the axle is misaligned.
And for security?
Okay, check the security and whether there's excessive play at the spring, anchor and shackle bracket pins and bushes, and check for deterioration of a rubber bush resulting in excessive movement.
What do you mean when you say excessive?
All right, the manual deals with this in different ways, so let me give you some examples. We mentioned earlier on, sometimes it gives you specific dimensions. So it says in the manual that side play at a spring eye mustn't exceed 6 mm. Another example, when it talks about play in wheel bearings. For front wheel bearings, it says excessive play. For rear wheel bearings, it says excessive play indicating severe maladjustment or wear.
Okay, any more while you're at it?
Yep. When it talks about beam axles and kingpins, it says a kingpin loose in the beam axle or its pin retaining device missing. When it refers to wearing kingpins, and that includes the bushes, it's got to be so bad that it's likely to adversely affect the steering of the vehicle.
And that's why you need experienced people testing and not just any old Tom, Dick or Harry.
Yeah, I prefer Rob, Dick or Harry and less of the old, if that's all right. Now we need to talk about the anchor and shackle brackets. They'll fail if they're loose to the chassis or if there's a retaining device missing. When a modified bracket's fitted, there may be more holes in the bracket than in the chassis, and this isn't a reason for ejection. Damaged or corroded so that it's seriously weakened. A spring saddle is loose to the spring. A nut or bolt securing the spring to the axle is not secure or is missing.
What else have we got?
Like there's torsion bars, and they'll fail if they're corroded or pitted so that the thickness of the bar is reduced and seriously weakened. There's insecurity or play at an end fixing. The adjustment assembly is inadequately locked. An attachment bracket is loose, or if it's seriously weakened by damage or corrosion.
And that just leaves bonded fluid, gas and air types in my calculations.
Is that all? Well, might as well start with bonded then. Failures on this type are if an attachment is loose or seriously weakened by damage or corrosion, if there's failure of the bonding between rubber and metal so that part of the unit is likely to become displaced. It's a good word, likely. It kind of means you're expecting it to happen. It also fails if it no longer functions due to damage or deterioration.
Okay, fluid, gas and air systems?
Right, if I discuss the different components one at a time, it should be easier. So units or accumulators fail if they're displaced or totally deflated. Damaged or deteriorated so it's likely to fail. Fouled by moving parts likely to cause damage or restrict travel. There's leaks. It fails if there's a leak anywhere in the system. Then there's pipe work. Supply or interconnecting pipes so damaged or corroded that they're seriously weakened or they're insecure. Leveling valves fail if they're insecure. And finally, movement. So when you're doing the bounce check on each corner, if there's no suspension movement at all, it fails.
Any issues that we've not dealt with, Tom?
Oh yeah, there's a couple of things we need to talk about. There's a type of suspension that's not obviously represented in the diagrams in the inspection manual. And although it looks similar to McPherson strut, it isn't McPherson strut. It's actually the same principle as diagram 2. And by that, I mean the spring load is imposed on the lower arm. So we need to jack it under the suspension, and care should be taken not to cause any damage doing this. And I have to say, there's a lot of vehicles about made by different manufacturers with this type of suspension. Even brand new vehicles have got it.
And on some vehicles, the springs need to locate properly when it's lowered, don't they?
Yeah, and you need to take care when you're jacking vehicles with shortened or lowered springs. Provided the spring ends locate correctly without assistance when the vehicle is lowered into the normal running position, this is not a reason for rejection.
And other vehicles have play in the upper support bearing, don't they?
Oh, for example, like the Ford KA upper strut attachment, yeah. They're designed to locate in the body as the suspension is lowered. And when they're hanging, they can have as much as 10mm vertical play or 6mm lateral play.